This video lesson will cover the introductory notes for Unit 13. Unit 13 is labeled Free Energy, and it comes from Chapter 19 in the book. The pages you're looking for begin on 785 in the book. For a long time, scientists have asked themselves whether or not a chemical reaction or a physical process is spontaneous, meaning it's likely to happen without any outside influence. Scientists have noted that some things happen spontaneously, where other things happen non-spontaneously, or they don't happen at all, unless it's pushed or stressed by an outside force. Take, for example, the rusting of iron. If you just lay a piece of iron out and allow it to be exposed to oxygen, it will spontaneously form Fe2O3, or iron oxide solid. This chemical reaction happens in ambient temperatures just outside. Of course, it happens when the temperature is warmer, but it still happens spontaneously, where other things can sit in a beaker forever and never really react without adding some energy or some sort of pushing it or forcing it together. Scientists have often identified spontaneous processes as irreversible. But as we learned in our kinetics and equilibrium chapters, that chemical reactions can be reversible. They are more likely tend to favor one side of the reaction or another, but you can force the reaction to reverse assuming that you change the temperature or pressure, which means that for spontaneity to occur, you need to consider both the temperature and the pressure at a specific condition. Another example is ice melting. If you take an ice cube out of the freezer and place it on a table, as long as the temperature is above the freezing point or melting point of water, the ice cube will spontaneously begin to melt and form a puddle until it is all melted. This happens without any outside interference, just simply being there, it spontaneously happens. But as we know, this process is reversible, and it can be reversed if the temperature is lower than 0 degrees Celsius. The water will then begin to refreeze. So the process is reversible, but only when temperature and pressure are considered. Now, I'm going to stick to the statement that spontaneous are irreversible as long as temperature and pressure are identified. So, in other words, if you take an ice cube and it's above 0 degrees Celsius, it's going to melt automatically. And it is unlikely or irreversible unless you change the temperature. So, it is going to stay as water, going from ice to water in warm temperatures. Now, the opposite of spontaneous and irreversible is non-spontaneous, reversible. Again, these processes are specific to temperature and pressure, and to be honest, I'm finding it very difficult to come up with a specific example of a chemical reaction that is non-spontaneous or reversible at the same temperature. Even a physical process like melting of ice requires the change in the temperature or change in the pressure for the reaction or process to go in reverse. The example in the book that they give of a non-spontaneous situation is, imagine you've got a piece of ice and it's sitting in a table or sitting in an environment where the temperature is right at 273, and maybe it's a fraction of a degree or a fraction of a Kelvin above freezing. So you're looking at 273.00001, where the temperature is close to 0 Celsius but a little bit above. And technically, if you're able to look at the ice on a microscopic level, it's both melting and freezing at the same time in a reversible, non-spontaneous way. Another example that comes to mind is, imagine you've got a sealed container of water, and it's sealed at the top so no vapor can escape. And you've got some of the particles escaping as gas and some of the particles as gas reforming liquid. This process is happening equally in both directions, and so in this case, the water vapor and liquid water are in a non-spontaneous, reversible situation, which means the water particles and the water vapor particles are changing states of matter inside the sealed container without any outside interference, which makes them non-spontaneous and reversible. Now you might be asking yourself, why do I care whether or not something is spontaneous or non-spontaneous? But in the grand scheme of things, scientists have always been asking us this question about why. Of course, chemistry has always been the study of what, but now this is the question of why things happen. This is like the underlying logic behind chemistry or just the natural world around you. Why do things happen spontaneously without any outside interference? Why does a brick fall to the ground when you hold it above? Why does ice melt when it's in atmospheric conditions above freezing / melting point? This is the why that we have been asking ourselves, and now we can actually quantify the why using what is known as free energy. Now, some common misconceptions that have been passed down over the years but have since been squashed out is that all things that are exothermic are spontaneous. You start a piece of paper on fire, it spontaneously continues to burn without any additional outside force acting on it. But that's actually not true. There are plenty of examples of spontaneous situations where the action or the chemical or physical process is indeed endothermic. Take, for example, certain substances that, when dissolved, actually absorb energy from the surroundings rather than release the energy. These sorts of things have a delta H of solubility of actually greater than 0 kilojoules per mole. So in those specific circumstances, there must be something else acting on the system overall that can attribute to the situation being favorable or spontaneous, not just the enthalpy of the solution. The answer to that question is entropy. Entropy is disorder, and it's part of the second and third law of thermodynamics, which says that the entropy of the universe is always positive or always increasing, meaning disorder is always greater than or equal to 0, which is a concept that we'll discuss in class at a later time. Now, don't get me wrong, the most common examples of spontaneous situations, whether it be a physical process or chemical reaction, are indeed exothermic. But the fact that there are some endothermic spontaneous processes means that there must be something else acting on the system. And as I'm pointing out right now, spontaneity or spontaneous situations depend not only on the enthalpy, but also on the entropy of the situation. Now, soon we'll combine the concept of enthalpy, which is delta H, and entropy, which is identified as delta S, and combine them into what is known as Gibbs free energy. But that's going to happen at a later date and time. That takes care of this video lesson. Thanks for watching.